We live in a finite world. It is an immutable part of our plane of existence, so infinity sits out of our reach from our lowly finite viewpoint. But just because we can't hope to reach infinity doesn't mean we can't count past it. Let's start with the concept of cardinality. Every atom that exists within our reality can be paired with a natural number, the numbers we usually use for counting. Numbers that describe the number of objects in a set are referred to as cardinal numbers. The cardinal that describes the number of objects in a set is the cardinality of the set. Now, looking at the number line, let's create an infinitely large set of squares, enough that we compare each square to a natural number. This means that the cardinality of this set of squares and the cardinality of the set of all natural numbers is equivalent. The number used to refer to the cardinality or total amount of natural numbers and this set of squares is aleph null, the smallest form of infinity. But what if we wanted to count past it? Adding another square does not change the cardinality of the set. Simply move every existing square one place higher and place the new square in the leftover spot. To count past aleph null, we must not look at the cardinality of the set, but instead the order type, using ordinal numbers. Ordinal numbers do not describe the number of objects in a set, but rather how they are arranged. The order type of a set is the first number that comes after the cardinality of a set. Every cardinal before aleph null is also considered an ordinal number, and every well-ordered set that can be created will describe a new ordinal number, since being well-ordered requires an order type. Notice how the set of all natural numbers plus aleph null do not currently contain an order type. Since the set is well-ordered, it must have an order type, but it cannot be any natural number or aleph null because the order type of the set is after the last number in the original set. We now need a new number that comes after aleph null, which we call omega, the first transfinite ordinal. After omega comes omega plus 1, omega plus 2, omega plus 3, and so on and so forth. Eventually, after continuing to count upwards an infinite amount of times, we can reach omega plus omega, or omega times 2. These ordinals are not bigger than the set of all natural numbers, but instead describe what comes after them. However, the set of natural numbers and all transfinite ordinal numbers is still well ordered, meaning that it must have an order type, and thus describe a ordinal number. We call this number Omega1. The cardinality of the set Omega1 describes is called aleph 1, a bigger infinity, longer than forever, outlasting eternity.